Today we are going to be giving a basic overview of the VEX Pneumatics system. This video is intended for students in VEX Robotics who have never used pneumatic systems before and want to learn more about how they work.
First, we will go over why pneumatics are important. Then, we will explain the key components used in a pneumatic system and how they work together. Afterwards, we will go over some basic building techniques for pneumatic cylinders. Finally, we will give a short tutorial on how to implement VEX pneumatics in VEX code. Pneumatics are a great secondary source of motion. Pneumatics are unique because, unlike motors, they translate motion linearly and not rotationally.
Pneumatics are strong, yet lightweight. Depending on how you incorporate them into your design, they can be used for many systems that require a push and pull or lift.
It's important to learn about pneumatic systems so that you can understand a broad range of mechanical concepts and apply them to your robot's design. Here are the essential components of any pneumatic system. This is a pneumatic cylinder. The cylinder has a port which lets air go in and out, an end which is where you can use screws to attach the cylinder onto your robot, and the piston which comes out like this. There are two types of pneumatics, single-acting cylinders or double-acting cylinders. Single-acting cylinders only have one port which lets air in or out. The piston can only be controlled to push out, and it retracts using a spring. Double-acting cylinders have two ports for air. This means that the airflow can be controlled to either push the piston out or retract it back in. The system itself is controlled by the solenoid, which receives digital signals from the V5 brain. Depending on the signal given, the solenoid will either open or close a switch inside of it to let air in or out. If you're using a single-acting cylinder, then you need to connect it to a single-acting solenoid. Similarly, a double-acting cylinder needs to be connected to a double-acting solenoid. The solenoid is connected to the brain by a solenoid cable. The cable is connected from the solenoid to one of the digital ports on the brain. The reservoir is basically the air storage. Once you fill the reservoir with air, it can power the pneumatic pistons. In VRC, it is legal to have a maximum of 100 psi in your reservoir. Last but not least, you have the fittings and tubing, which connect all the parts together. The tubing allows air to travel from the reservoir to pneumatic cylinders.
Now that you know about the components of a VEX pneumatic system, how exactly are they used together? The first technique we can use to mount a pneumatic cylinder is to simply attach the end of the cylinder to a rigid body using a screw and a nylock. This technique prevents the pneumatic from rotating and is very sturdy. The second technique is similar to the first technique, but incorporates a caps nut to make a screw joint. This allows the pneumatic cylinder to rotate. The third technique also allows the pneumatic to rotate, but it has its ports perpendicular to the screw joint. Pneumatic cylinders move linearly when activated. This means that if you want to push or pull anything on your robot, the linear motion is limited by the length of the piston's full extension. The linear motion of the pneumatic cylinders can be translated to rotational motion. The speed and distance can be altered by moving the head of the pneumatic closer to the pivot point of the object.
Let's write an example program in VEX code using the competition template that can extend and retract pneumatics using a controller. What this program does is send a digital signal to the solenoid. When the signal is true, the piston extends, and when the signal is false, the piston retracts. The first step is to configure your solenoid in the settings. To do this, you open the configuration settings on the top right and select Add a device. Scroll down to the 3-wire option and click on it. Then, select the digital out option. This setting allows us to send a digital signal out to the solenoid. The port that you select depends on the port that you use to connect the solenoid to the robot. Let's say in our case, we are using the A port. To control our pneumatic, we will create two functions, one that extends the pneumatic and one that retracts the pneumatic. Let's call these functions extend new and retract new. In the extend function, set the digital output to true, and in the retract function, set the digital output to false. Now we will assign the buttons that call the pneumatic callback functions. Find the user control function. In the while loop, refer to button A and call the press method with the argument extend new. Button B is the same, but we'll call retract new instead. Now let's test it! We have here a simple pneumatics layout with the piston, solenoid, reservoir, and cable connected to the brain. If we press the A button, the pneumatic will extend. If we press the B button, it will retract.
So that's it. Hopefully now you can utilize these powerful components in your own robot builds. Some typical uses of pneumatics include pneumatic wings, pneumatic-powered blockers, and pneumatic catapults. For more in-depth details on VEX Pneumatics, consider visiting the official VEX sites. The links are in the description below.